Hello everyone. So today we are going to solve 9th of August problem from GeeksForGeeks, that is largest zigzag sequence. What is this problem is? So we have given a input as a matrix, 2D matrix, and we have to find out the zigzag sequence that starts from the top and at the bottom. And two consecutive elements of the sequence cannot belong to the same column. Okay, what it is saying is we have considered this, we have this matrix. Uh, 3, 1, 2. Let's take this input to our board. And so we have given this matrix 3, 1, 2, 4, 8, 5, 6, 9, and 7. So any element if we have chosen like in this row, let's suppose if I take this element, I cannot take this element. So according to this problem statement, like two elements of the sequence cannot belong to the same column. So we cannot take this. We can take this element. We can take this element. And again, next, if I take this element, we can take now this element because this is not, they are not in the same column like that. They are not in the direct sequence. They are in the same columns, but they are not in the direct sequence. If we take this element, we cannot take this again. So similarly, we have to find the maximum sum that we can achieve. Coming to so what are the possible sum in this like for this input matrix will be like if you consider this element as the first element, so 3, and you cannot take this 4. So what you can take this as, let's suppose 8. If you are taking as 8, it will become 3 plus 8. And the next element you need to take 6 or 7. So if you take 6, the sum will become 17, and if you take 7, it will become as 18. So now you have to find the every path sum basically from top to bottom. And next, if you will take this one element, what will be the path? If you take this two element, what will be the path? So every path, finally you have to end up with what is the maximum sum that you will achieve in the final row, in your bottom row. So in this case, what will be the final maximum sum that can be considered? So 2, 8, and okay, so 386, 387, and we can take if I'm taking one, so it would be 149, 159 will become the maximum, that is 15. And if I taking two, then can be 2 plus 8, 10, 17, or 2 plus 4, 6, 6 plus 9 is 15. 2 plus 8, 10 plus 16, I guess 17 or 18. Okay, 387 is become the maximum sum. So 3, 8, and 7. So that will become as, yeah, 387 is the maximum sum. That will become as the 18. Coming to the problem, how we are going to solve. First, I will tell you like how we cannot use the greedy here. Like why not greedy? Let's suppose if I'm taking this example, and greedy, I mean to say to take the maximum value at the current subset. Like if you are checking in this first row, what is the maximum? What is the value that we can take? We can take any value, right, to find out our answer. But if I'm greedy, I will take as a 3 because 3 is the maximum value among the 3, 1, and 2. This will not given to us the answer. In this case, it will give, but consider this example, it's 40, not 4. So in that case, what I'm doing is I am taking 3, then I'm taking as 8, and I am taking the maximum as the like in this example as a line, let's suppose. But if I'm taking 3, 8, then I will no, I would not be able to take 9. So I will take as a 7, second largest element. So it will not give me the correct answer, right? Because 40 is the maximum value that I can append from here to 40 and 9. This will give me the maximum value. So that's why we cannot use the greedy. Coming to the next problem. Okay. The problem, like if you're a beginner, I would suggest you to try with the brute force approach first. Try to solve with that, and based on that, you will going with the optimization approach. That is the best approach. So brute force try to write the code. Okay, what it is saying is first you have to take any element, then try to take not the same column element from the next row, take other elements, and similarly you need to maintain it. Okay, to maintain this, what exactly we need that we need to check. I mean to say is consider we have this example. So what we need basically, we need for every row to find the like whichever row we are currently, what is our current row number, which is the column that we have previously take in the in our previous row. Like let's suppose if I'm taking this row as an example, consider I am in this row and I found out the maximum value till this row. So for to find out which value I will take from this row, that will be based on which particular like value I have taken in the previous row. So basically, if I took the 3 value, I cannot take this 40, right? I will take as a 8. So I need to maintain the column also. We need column also. Okay. What are the other details that we need? We need input matrix, of course, that are the in the function. What are the other details we need? We need the maximum value also. That will track our maximum among the final row. Okay, that we need. So these 3 details, I guess we need, and based on that, we will need to find out. Coming to the solution, how we will be going to approach is uh, consider. You will better understand when I will write the code for this brute force approach. uh, Consider we have this matrix dot length, and what I need to do is I will take as maximum as an array because in Java we need to pass by the value. So I will consider it as an array, and I will first I will maintain the take as the maximum value. Like let's suppose our maximum value is maximum of 0 is matrix of the first element. Okay. What I need to do is I will take, I will, let's suppose I have some input function. Consider this is a black box function. Consider if I'm giving the input value, okay, this is my first row. If I'm starting from here, what will be the my maximum sum from for this particular element if I'm starting from here? This will give us some value. If I'm starting from here, what will the value? If I'm starting here, what will the value? This black box is responsible for taking the like, okay, if you're taking this element, you are not going to take this element, or you are going to take this or this, any elements, and based on that, it will give us the maximum value. So I will create a one function for that. Uh, for int consider, I'm going to that part, and I have some black box function like compute zigzag max value something. And what I need to pass is I need to pass matrix, and I need to pass which I am currently row. So my current row is 0. My column is I, and that I've achieved till now. The sum is that is the mat uh, that we have not achieved any sum yet. So I'm going to take that, and what is the maximum value that we need to track. So these 3 values we need to pass, and it will compute the maximum sum for this particular matrix from starting from here. And finally, what I will do is I will return the maximum value that I achieved from this particular black box. Coming to this method, how we will write is compute. My current row is so 0, we can say, and current column is C column, and current sum is C sum, and maximum value that we have taken. Okay. We will discuss like how this recursion will work. But coming to the point is, okay, so it means we have take this C row and we have to go into this next row. Okay, we have to find out next row. So basically, one point of the time, if you were going to this row, this row, this row, so finally you will become as the final like base condition will we need to write it here, right? So my current row will become, if my current row will become mat dot length, that is if I'm out of the bound of the matrix, what I will do is I will just take the maximum sum that I have achieved till now, and with the current sum that I have achieved till this point, and I will out of the recursion from here. This is the base condition that we need to write. Next point is, okay, if I took this particular element, what is the next element that I can take? I cannot take this element, right? I can take any other element. I can take any other element other than the same column element. Okay, same column element. I can take any other element. So I need to traverse the then each and every column. It means so for that, p is less than dot length p plus plus. I need to check if my if I'm traversing this column and this is not equal to my current column, what I need to do is I can compute the maximum sum from this here. So I will do is matrix. My current row will become increment by 1 because I'm going to the next row. My current column will become as C because I took this column, and my current sum will become I need to take the current row, and current column that I need to include in my sum, and my maximum will keep as it is. So this will compute the maximum sum for from the next row. And basically, finally, it will return us the maximum. It will track out the maximum, whatever the maximum we will achieve from here. So, and it will return the final maximum. Let's do the dry run for this. This okay. It should be maximum of 0. Okay, let's see. Yeah, it is working, but the TLE error is there. Why? Let's see what is the time and space complexity for this example. The time complexity, as you can see, first we will see time complexity. So here we are doing the big of n method, and big of n is the outer for loop, and we are doing the compute z maximum. What is this? This is doing is this is big of one approach. This is big of again n. N is the metric root length, and we are doing the compute z maximum. This is going till each row, like one by one, each row it is tracking care of. Finally, when it will out of the bound of the matrix. So it means we are going again here big of n approach. So it is big of n square and big of n square inside the big of n. So this is big of n cube. So basically this problem that we wrote the code, this is time complexity is become as big of n cube, and space complexity is become let's suppose space complexity is that we are taking care of, this is big of 1, so we can say as a constant, and we are not taking care of any extra space other than that the recursion space. So we can say we are taking as the big of n space, that is the recursion space that we are taking. Okay, coming to that, how we can optimize it. This is again, this is not going to be acceptable, like because we have the constants of n 100 and matrix of ij are all the positive values, so we can optimize this. How we can think of the optimization approach? Let's take that same example. How we will see. Okay, coming to this point, consider we have again matrix 3 1 2 and 4 8 5 6 9 and 7. How we will going to do that? Consider what we need here is for, let's suppose I am in this row, row number 1, that is 485. What I need is for this particular element, what is the maximum sum we need from this particular row? Okay, right? What I mean to say is, like, let's suppose if I am in this row, if I'm in this element, I cannot take, it means if I'm taking this element 4, for sure I have not took this 3 element, right? But there can be the other element that I have to took. But which element? If I'm taking the maximum element from these two, that can give me the like maximum possibility of the answer, right? If I'm taking one, then it doesn't mean right the maximum answer, right? If I'm taking two, then it gives me my maximum answer. Same for consideration for 8. If I'm taking the eighth of the element in this row, I for sure I will not take the 1. What I will take is the maximum answer I will get it from 3, right? I will not take from 2. It I can take 2, but it will not give me the correct answer, right? So to take the maximum, I will need that's 3. So what I will do is for every row, what I'm doing is for every row, I need the maximum element that previous row that has, and second maximum element that the previous row has. So if I take these both of the elements, if I have the maximum column number and second maximum column number, what I will do is for every element I can easily find out, right? So what I means to say is, consider this example again. Okay. So in this, consider I am in the row 0. So what I meant to say is initially I have a row as, so what is the maximum, uh, maximum row number, that is 0. So 3 is the maximum and 2 is the second maximum. So this is the second maximum column number. I'm tracking this. I will explain why in the meantime. So this is my maximum column number. This is my second maximum column number. And for this element, what I need is for 4, like I will for sure take, okay, 4 is, if I'm taking, I will not take as a 0, right? I will take as the, what is the my second maximum. So second maximum is the 2. So I will append this 2 plus 4. This can be a possibility of the one answer. So 2 plus 4, I will take this so that I can optimize this better. If I'm taking as 8, I cannot take 1. So what is the maximum? 1 is not a maximum row, right? So I will take as the maximum element from there. That is 3. So 3 plus 8 is become my second possibility. For 5, I cannot take 2. I will take as a 3, that is the maximum. So that is 3 plus 5. So now you can understand we are taking care of the maximum and second maximum so that when I am in the particular column, I will not take the existing column. I will take the remaining elements, the maximum value that I will take, and to taking the maximum element in the effective manner that I am taking care of the maximum, second maximum. Otherwise, the same problem will occur. Like for every row element, you are going to again to traverse for the every element and you are going to check, okay, whichever is the maximum element, and based on that you are going to append that in your sum. Okay, so for that part, I'm taking care of this so to reduce that over headache of the traversing again and again. Okay, so coming to this, how we are going to solve this with this example, it will better explain with the code that I'm trying to show here is uh, like okay, remove this existing code so that we'll see how it will work. So we have the matrix dot length and we have this, okay, what we will do is, first we will take as the previous row so that we have to tracking care of, okay, what we are going to do. So we can make as the previous one row, that is this one. And what it will store is, so it will store for the first row every element that we are going to think of. So previous of I will become as the initial row is 0 and my column number is I. So it will store them. And for the next row, I need the maximum and second maximum from the first row. So let's suppose I'm getting some, I will make again as a black box that give me like maximum and second maximum of that particular row of the element. So get max and second max column values from the matrix of 0 I need because from the first row, and max column will become of a of 0 and second maximum column will become as a of 1. So this give me my maximum column and second maximum column. We will go come to this method how it will be going to compute. But for the remaining matrix for int I equals to 1 to n, what I'm going to do is for this particular row, I need to check, okay, this is the maximum that we have achieved till now for whatever the maximum what we can achieve from here. So for this part, uh, consider like if I'm on this element, I will check if C is not like for, okay, then what we need to do is for int j equals to 0 to n, we have to traverse first for each and every element. And I will check if my j is not equal to my maximum column. So it means if j uh, if j is equals to maximum column, it means whatever the maximum column that we have achieved in this row, that is the 3, that is the zeroth column, and the element is the 3, that is the maximum column that we have achieved. And if I'm on this element, so I cannot take 3, right? I will take the second maximum, that whatever it is. So second maximum is 2. So what I meant to say is previous of this particular matrix, what it will become is, so we need to maintain the 2D matrix here previous. Why? Because we cannot track because we need the previous values also. So either we can take as the two matrices, previous one and previous two, or I will take first as the 2D matrix so that it will be easy to explain. Then we will, in the optimization further, we can go with the single matrix. So previous of 0, 5 is become this, and previous of this particular I and j, what it will become as previous of previous row and my second maximum column plus whatever the current value of this matrix. And if j is not equal to maximum column, it means like let's suppose consider this element 8. Maximum column is the 3 for the previous row, but I'm not in the same column, so I can take that maximum value, right? So for that part, what I will do is previous of I of j is previous of I minus 1, and maximum column we can take, and again I will take the current value. So this will give us, and for each of the row, then I will take the because I'm this first row, I need the again the maximum and second maximum column, so that for the next further rows. So again, I will do is A equals to get maximum and second maximum column. This time we need for the previous of this current row. If we will take this, and my maximum column will become A of 0, and my second maximum column will become A of 1. So now we have the details, and finally our final row will become as a maximum element from the top to bottom. It will have all the maximum elements. So what I will do is return previous of row minus 1, that is last row, and what is the maximum column that it got. So it finally maximum column, that whatever the maximum value is it has, it will return that. So for writing this particular method, we have given some array. Let's suppose this. Okay, how we will find the maximum and second maximum? So consider we have we have array as this 3, 1, and 2. Let's suppose my maximum and second maximum are nothing. Like you can say maximum is minus like let's suppose maximum is 0 and second maximum is considered as the this one. This will be easy. So maximum is 0 and second maximum is this one. And for the next element, I will check if this element is greater than the maximum. So it means the maximum element might will be changed, right? And second maximum will become the maximum, and maximum will become this new element. If this element is in between of them, so it means second maximum will become this element. And if it's less than both of the element, it means there is nothing to change. So what I mean to say is int, consider it maximum is 0, and second maximum it is 1. So it's just a algorithm to find the maximum and second maximum column number from this particular array, nothing else. So what I will do is I will check for the first element if my array of 0 is greater than array of 1. What it means is it means first element is greater than, and so consider if this is the case, base case, I'm taking care of extra. Like if array of 1 is greater than array of 0, consider I'm taking as the maximum as 0, maximum as the 1, but consider this as the 10. So if this is the maximum, then I will take as the maximum this, and second maximum as the 0. So my maximum column will become as 1, and second maximum column will become as 0. And I will then going to traverse from the third element till the last element, and I will check if my array of I that is came is greater than my maximum that I've achieved till now. So it means my second maximum will become my current maximum, and my current maximum will become this I. Coming to this part, and if array of I is less than maximum column, so it means this is less than. So there can be two possibility. Uh, Either array of I can be greater than my second maximum. If that is the case, then I will simply make the second maximum will become as a I, or otherwise we don't need to change, right? Because array of I is less than second maximum and array of I is less than maximum column. So array of I is less than both of the values. So there is nothing to change here because maximum second maximum will remain same. Okay. So this will give us this values. Okay. We need to finally return this. So return new int, and what we will return is maximum column and second maximum column from here. I'm writing this code in Java, but the algorithm will remain same as you can write in your own preferred language. Let's see. I think it should work. Okay, it is returning at 17. Uh, in previous in 0 n. Okay, matrices of 0 I. Get maximum. Maximum is okay. If I'm taking this 3 1, so it is array of 1 is greater than array of 0. No, if that is the case, then maximum and second maximum will swap. Otherwise, they will remain same. And if I'm going to this, if array of I is greater than maximum column, so it means second maximum column will change and maximum column will become I. Otherwise, my if array of I is greater than second maximum column, so second maximum column will change. And for I equal to 1, say 2 to n, 0 to n, if j is equals to maximum column, if j equals to maximum column, then it means if we need to take the second maximum column from the previous row. And if it is not, then we can take the maximum column that we have from the previous row. And we are taking this for to compute the next values from the previous of I, yeah. And okay, and we will finally return the final and maximum column values. Okay, what we are doing here is consider this example as 3, 1, 2, 4, 8, 5, 6, 9, 7. So what I'm making is initially my previous is the same for this row. Coming to this point, my uh, maximum here is 0 because 0th row is maximum and second maximum is 2. This is 0, this is 1, this is 2. Okay. And I am in this row. So for this particular row, my j is not equal to maximum column. Maximum column is 0. J is equals to maximum column, then I will take the second maximum column. So it will become as 4 plus 2, that is 6. And for this, it will become, it is not equal to maximum column. So it will take the maximum column value, that is 3. And okay, I think, yeah, this is the mistake because array of I is should be not maximum column. It is array of maximum column and array of small maximum column. To take those values. Okay, yeah. Let's try to. Okay, yeah. So we need to handle this is the base case that I forgot. Like if n is equals to 1, it means 1 is the one matrix, then we will just we don't need anything else. So we will just return matrix of 0, 0. Because this is giving TLE because we are doing explicitly array of 1 that is not possible in this case. So let's try first with the custom input sum array of 1 5 and take like this 40. Let's see. Okay, yeah. So let's try to, yeah, it is working. So I want to tell you like this is I don't think this is first of all difficulty should be easy level. This should be medium level problem because to coming this maximum and second maximum and to taking this like okay we are going to track the every row maximum values and we are going to use a previous row to this row. That is the first part. And so coming to the time and space complexity for this, so this is not taking any time. This is big of n time and this is big of one approach. So this is big of n time this is taking. Coming to this method, this is taking as the big of n and simply this is only big of n method. So this is big of n. Here we are running two loops. So big of n square and this is big of n only. So big of n plus n. So this is become big of n square finally. So time complexity of this program is big of n square. Coming to space complexities, we are using 2D matrix that is big of n square. And I think that there is nothing else that we are using that. So that is big of n square. And there are many other optimizations that you can do. You can think of that previous matrix. Now we are taking care of the 2D array matrix and we are taking care of the every row, but we don't require every row, right? For this particular row to compute 697, for this computing the maximum sum for this row, we need the previous row only. We don't need the previous rows. So that is the one optimization that we can do here. And so I will leave that to you, and but you can try this. Okay. Thank you, everyone. If you like and learn something new, so please like, hit, and subscribe the channel. Thank you.